Alright, today we're going to look at this 8-4. We're going to look at adding and subtracting polynomial. So, here's our goal. We're going to add and subtract the rational expressions, and then I even put some uses for these, for Michael.
Sure.
So there are some uses for rational expressions. Again, I want you to remember what they look like. So tying in what they look like, tying in with those vertical asymptotes, because remembering what x can't be, tying it in with a domain. Alright, so write these down. So let's go on to this next one here. So again, going back to our prior knowledge, let's write this down. 8 over 25 plus 16 over 25. So remember that the denominator is equal to like the number of slices that a pizza is cut into. So think of a pizza that's cut into 25 slices and think of what the size of those pieces of pizza are. That's what that represents. So you're getting 8 of size 25 pieces of pizza, and you're getting 16 size 25 pieces of pizza, right? They're all the same size, so we don't have to find a common denominator because we have already divided the pizza into equal sizes. So what is 8 plus 16? 24. So we have 25, 25, 25. Every one of our fractions has a common denominator, and that's what we're shooting for. All right, let's go to the next one. 7 over 6 minus 11 over 32. Write this down. So first thing we're going to do is we're going to find the common denominator, right? We're going to think about finding a common denominator. So step 1 of our steps was to factor the denominators. So I'm going to factor this as 2 times 3. This guy factored is 2 times 2 times 2 times 2 times 2. Because factoring a polynomial is like writing it in terms of its prime binomials or polynomials, whatever it is. So a number factored is kind of like writing it in terms of its prime factorization. Very equivalent. Does that make sense to you? So what we do is we always write down what the first fraction has. What does the first fraction have? A 2 times a 3. What does the second fraction have that we haven't already written down? What have we already written down from the second fraction? We've already written down one of the 2, so we don't need to rewrite him. So I'm just going to write down 4 2's. And that's going to be my common denominator. We're not used to looking at it in terms of its factors, but with polynomials we are. So it's the same process. Now we're going to do this. What do we have? What do we need? This fraction does not match this one. We need all 3 of the denominators to match. So this guy has a 2 and a 3. What does he need? He needs 4 2's. Okay, and if I do that to the bottom, I have to do that to the top. Does that make sense? Look at the second fraction. What does he have? He has 5 2's. So we have 1, 2, 3, 4, 5 2's. What does he need? He needs to have a 3. So I need to put a 3 on top. Now do you see that all 3 denominators match? They all have 5 2's and a 3. They all have 5 2's and a 3. They all have 5 2's and a 3. Does that make sense? So now, what is 7 times 2 times 2 times 2 times 2? Which is really like 7 times 16, right? So 112 minus 33 equals, so I get 79 over, and if I multiply 2 times 3 times 2 times 2 times 2 times 2, I get 96. Whenever it's a polynomial, factors of a polynomial on the bottom, we don't multiply and we don't FOIL it, we don't distribute it, but in this case, because these are numbers, we go ahead and simplify. Does this make sense to you? The exact same process is what we're going to apply in the next question. Write this down. Yes. Alright, so now these guys already have a common denominator. So 4x. Do all 3 denominators match? 4x, 4x, 4x.
Correct.
So all I have to do is add the top. Now I can simplify this, right? Because really 4 and x are connected by a dot. Dots don't have arms. So they're not holding, the dot's not holding the 4 and the x together like a minus and a plus does. So this divide by 2, we get 5 over 2x. What restriction do I need to have on x? X cannot be 0, right? If I was to graph 5 over 2x, we would have a vertical asymptote at 0. Make sense? Alright, let's look at the next one. Alright, this one, write this down. 5x minus, parentheses, 3x plus 6. So using our prior knowledge, I'm going to distribute this negative, drop down the 5x, get negative 3x minus 6. Combine like terms. So we're going to apply that prior knowledge. First thing we're going to do is we're going to put this in parentheses and we're going to distribute this negative. Right? The denominator is going to be x minus 2 because the first fraction and the second fraction, their denominators match. All three fractions have the same denominator. So we have 4x minus x minus 4. Does that make sense? Equals 3x minus 4 over x minus 2. So what restriction do we have on x? Does that make sense? Alright, let's look at this next one. So again, going back and grabbing our prior knowledge. So what we do first, distribute. So we're going to have negative 4x plus 20 plus 8x minus 8. Combine like terms, 4x plus 12. Alright, so let's apply that prior knowledge to this problem. Step 1. First thing we're going to do is we're going to find a common denominator. So we have 2x plus 3, x minus 1. Why is the common denominator 2x plus 3 and x minus 1? Alright, they're 2 prime 1, so we just add them together, right? We write down what the first one has. We notice that the second one's completely different, so we have to write them both down. Now we have to ask ourselves, what do we have, what do we need? So if I look at this first one, it only says 2x plus 3. I needed to say 2x plus 3 and x minus 1. So what does he need? What does he need? X minus 1. So I have x minus 1, x minus 1. Now if we look at the second fraction, it has x minus 1. We needed to say 2x plus 3 and x minus 1. So what does the second fraction need? He needs to have a 2x plus 3. So now all three denominators match. The first one, the second one, and the new one. So now, applying just what we did before where we distribute, that's what we're going to do. We're going to take 5 times x and 5 times negative 1. We're going to take a positive 7 times 2x and a positive 7 times 3. So we're going to get 5x minus 5 plus 14x plus 21. Combine like terms. We're going to have 5x plus 14 makes 19x plus 16 over 2x plus 3 and x minus 1. X cannot be negative 3 halves or 1. Alright, let's look at this type problem. We're going to first, again, go back and use this prior knowledge and apply it to the next problem. So write this down. Alright, the first thing we're going to do is we're going to distribute this negative to the first one. So we're also going to FOIL this guy. And after we distribute this, we're going to have negative x minus 2 times x minus 3. So FOIL this first one. 2x squared plus 8x minus 3x minus 12. Now I'm going to take the negative x times the positive x and FOIL these guys. So negative x squared plus 3x minus 2x plus 6. Now combine like terms. So we FOILed, now we're going to combine like terms. So this is going to be 1x squared. I'm going to add up the x's. So that's going to make 6x. And then I'm going to add the constants. We get minus 6. Does that make sense? Alright, so we're going to apply that prior skill to this example. So, starting from the beginning of our steps, step 1 is to factor. So I'm going to factor this, and I'm going to factor this. I always cross them out after I factor them, so I don't, forget what I did. I'm going to factor this, and this. Alright, one of the things that we have to remember is this negative. So we want to go ahead and distribute it now. So we're going to change this to a plus, this to a minus, this to a plus. So we want to make sure that we distribute that negative so when we get to the end of the problem we didn't mess up somewhere and forget about the negative, because it's really easy to do that. Alright, common denominator. Step 1 is to write down every single thing the first denominator has. The first denominator has an x plus 1 and an x plus 3. Now look at the second denominator. What does the second denominator have that we already wrote down? He has an x plus 3, so we don't need to write that down again. What does he have that we have not written down? X plus 2. So does that make sense to you? If they share it, we just write it down once. If they don't share it, then we have to write down whatever is left. Okay? Now, we got to compare. This guy only has 2 things. Our common denominator has 3 things. So which one of these things is missing? Which one's missing? X plus 2 is missing from this first one. So I need to multiply this first fraction by x plus 2. Now let's compare the second one. This one has x plus 2 and x plus 3. Mitch, what's he missing?
He is missing the x plus 2.
X plus 1. Okay? Happy words. So let's look at this. So now what I have to do is I have to FOIL. And I have to FOIL. So I'm going to FOIL these first two and have 2x squared plus 4x minus 2x minus 4. Now FOIL the second one, just like we did before. I'm going to take negative x times positive x to get negative x squared, negative x plus 1. Finally, we're going to combine like terms. So this is going to make 1x squared. This makes 0 plus 2x minus 3. So now we have to factor this. Notice this will factor. So because it will factor, we have to factor it. So what two numbers multiply to make 3 and subtract to make 2? So we have x plus 3 times x minus 1 all over x plus 1 times x plus 3 times x plus 2. So you can see that they have a common factor. We didn't know that until we factored them. So that they have a common factor of x plus 3. So our final solution is x minus 1 over x plus 1 times x plus 2. X cannot be negative 1 or negative 2 because those are where the vertical asymptotes for this solution would occur. Our assignment is page 586, 3 through 29 odd. Make sure you check your answers in the back. Also, remember that LCM is least common multiple, which is similar to least common denominator.